Welcome everyone. This talk is about the Flemish child benefit system. It's an application that we built the last 1.5 years. It took about 5 weeks since we were into production before we had our first crash. 2 weeks later, we had another one. These were just hardware issues. After that, the real problems, they still had to start. Okay. First, a bit of context about the project. The project that we had to build, it was basically, the basic rule was that we had to pay 160 euros to each child in Flanders. As you might know or not know, in Belgium, you have several regions. And the reason for our project was that there was changes in legislation. And for Flanders, there were new rules that we had to implement. If you put it like this, it sounds like a pretty easy ride. But as you might have guessed, it was a bit more complex. To start with, what we had to build was, we had to build an application for 5 customers. So in Flanders, you have 5 organizations that pay the child allowance. And for those organizations, we had to build an application. These customers, they pay over 900,000 families in Flanders. And it means that each month we are paying about 300 million euros a month to these families. We had a very strict deadline, so we had only 1.5 years to build the application. We had a very limited budget, of course, and as always, way too much scope. As far as the non-functional requirements are concerned, of course, audit logging, it was very important for us because we are dealing with a lot of money. So it means that this was a really strong requirement for us. Apart from that, we have the 900 families that we have to pay. So also batch processing, it was really, really important. And we had to get those payments out fast. We had to migrate the data from the old systems, from the payment actors, towards a new system. And of course, there was a lot of sensitive information in the application, so security is also very, very important. Apart from that, we had to integrate with the systems from the 5 payment actors as well. And as in every system, performance is important too. This is how we did it. We started off by building a context map of the system. And the luck that we had was that we built a similar application a few years before, and we knew the business very well, which allowed us to define the different boundaries, to define the different contexts in the system. At the moment that we had this, we started doing the dependencies between them in order to be able to scale our teams fast enough. So I think at the high of our project, we had a team of about 70 developers working on the system in order to get this delivered by January this year. Our approach for this was microservices. The reason why we chose microservices was because we had to scale our development teams. We had to be able for them to work on the different parts of the application in order to get it finished in time. So what we did was, we had the bounded context that we defined. Each of those, we made separate applications for them. So all of these applications, they are completely standalone, they have their own data stores, and that's what we built. Of course, after a while, we needed a way to have these applications communicate with each other. This is where a central event store came into place. And this is the place where we use AxonDB. How does the system work? Imagine there's a family somewhere in the system and a child is created. You have the you have the file management service where the child is added to the system. In the end, it will produce an event saying child created, which is stored in the AxonDB database. Afterwards, the payment service, it will pick this up and it will decide that it needs to pay this child at the end of the month. It will again produce an event, child paid, which is stored in the central event store. Imagine you have to communicate to the family that an extra child is added. The communication service picks it up, it sends out the letter, and again, it's stored into the event store. Very important in our system is the fact that not everything is an event. We started out with this, but pretty soon we noticed that we cannot solve every problem by events. Every communication problem, then I mean. At that point, we introduced RabbitMQ as a messaging system, and we use it to send commands between our services as well. One example for this one is, imagine you do a payment, but for some reason it cannot continue. You are missing a bank account number, for example, and you cannot pay the family. At that point, the system decides that it needs to create a task for the end user. It needs human interaction, and the bank account number, it needs to be entered into the system. Whenever this is needed, the payment service, it sends out a command, create task, which will be picked up by a separate service. It will create a task for the end user, so that the end user knows it has to do something into the system. At the end of that, there's also an event created, which is stored into the database. These kind of things is primarily for reporting, that we store these as events as well. This is what we built, and with this system in place, we made it. The beginning of this year, we went into production. And then we suffered. We suffered really hard. One of the reasons that we suffered is the fact that we built an eventual consistent system, and apparently it's really eventually consistent. Oh, sorry. Apparently it's really eventually consistent. As I said before, we had this team of 70 developers working onto the system, but these developers, they all came from an asset mindset, meaning that they were used to users having data entered into the system, and that this was all immediately transactionally consistent. Of course, in our system, it was not always the case. Because of the events, we have background threads processing events, which can cause things to be delayed. To make it even worse, we never saw those things during our tests. We only had limited tests. We didn't have any production comparable hardware, let's say, until like 1 month before we went into production, and that actually was our production hardware. So we had 1 month to test the system under stress. We didn't have enough time to do decent testing. The first testing was into production, and we suffered from these kind of things. What we learned now, that whenever you are building this kind of system, is that we need to make nice functional islands. In terms of Axon, it means that your tracking event processor, it needs to be fully standalone, and it cannot look over the wall towards another tracking event processor. Apparently, also event handling can fail. During the first test session we had with the customers in December, the big test session then, it lasted for about 15 minutes. After 15 minutes, apparently we had a bug into our system. Surprise. One of the end users was able to enter some data into the system that we did not expect. It threw a null pointer, and at that point, one of the tracking event processors, it went into an infinite retry loop. The complete system stalled. We solved this by, it's the thing that Albert referred to earlier. We have some kind of that letter queue mechanism in place now, where whenever something fails, we put the event that failed on the side. The file on which this event failed, it's marked as dirty, and all the other events, they can continue. All the events that are related to this file, they're also parked on the side. After the bug is fixed, we replay the failed events, and the system is working again. One of my favorites. We went into production. We had to do a data migration before that. And the way that we tackled this, we had some kind of canonical file format delivered. And all the parties for which that we had to do a data migration, they had to deliver us exports from their old systems into this file format. They didn't have enough time to do proper exporting, so we went to do production, and on day 2, we already got tickets asking us to do database updates to correct their data. We couldn't. Even worse, normally in this kind of cases you start out sending events to correct the data. We couldn't do that as well because we had so much scope that the only thing that we could for the application was enter data, not correct data. So it's something that, of course, if we would have more time, we would have prepared for that. But they had to wait for their fixes at that point. A bit related to that, apparently we made an error in the domain modeling, and right before the first payment, we noticed that something in the domain model was wrong. So we had to change it before the first payments went out. It means changing your events, it means redesigning your events, and of course we knew that we had to do that sooner or later, but we didn't have enough time to practice for that. We did it for the first time right at the moment that it was needed, but of course also under a lot of time pressure in order to get it fixed in time. We managed that. Same thing for our views. Developers, well, we write bugs, and we also had bugs in our views. So we wanted our views to be regenerated. We played with it a bit before we went into production, but we didn't have really proper knowledge for that at the time. On top of that, our customers, they want to limit the downtime as much as possible. Our event store for the moment, it contains about 60 to 70 million events per customer. If you do a replay for a view, it takes 1 or 2 days. It's not acceptable for them to have a downtime of 1 or 2 days. What we have in place now is some kind of blue-green view mechanism where we can rebuild a view in the background, and at the moment that it's finished, we can switch over to the new view and we deprecate the old view. A release later, we remove the old view. By now, we've been 38 weeks later. We didn't have any crashes anymore. And we never missed one payment moment. And of course, all our teams, including myself, we learned really a lot. We learned that whenever we are building new functionality right now, we have to think of eventual consistency from the start. We learned that we really have to build those functional islands and that you cannot look over the wall towards another functional island to fetch some data over there, for example. We still use our central event store, and we are making plans to move to Axon Server in order to phase out RabbitMQ for the commands. We still have the mechanism in place where we put events on the side whenever something goes wrong with a file. And also we are now prepared for event changes and view changes, and we have our things in place for that. And from time to time we still make mistakes, but by now we have our events in place, or when needed we create new events to fix data errors or other errors. As I said, with applying all those things, we pay tickets in time each month. In fact, this weekend we have another payment moment, which is always a bit stressy for us. But they will get paid eventually. My name is Robin Custers. I still am the architect of the project. If you have any questions, feel free. Yes.
Why did you choose for a central event store and not an in-store application?
Actually, you have both. If I go back a bit. So we have 2 levels of events. We have the events of each domain, which are stored in a Postgres database. And this is actually where we apply event sourcing. The events in AxonDB, these are what we call integration events, or what is called integration events. And they are used for communicating between the services. And also, these are the events we send to the outside world. So I said earlier, we do an integration with the systems from the payment actors. They also get our public events, actually. Yes? Sorry? Yes, we still use that. So yes. So the question was, are we still using the messaging bus for the that letter messages? Yes, we still use it, but it's indeed not as much anymore as we had in the beginning. In the beginning, I think the first days it was really filling up with thousands of events. By now, it still happens from time to time. We fix the bug, and a day later it's fixed. So all the teams, they have sort of as a mission to keep the number of dead letter events to 0. Other questions? All right. Thank you for listening.